Hi, welcome to part 3 of the Godot Tactics tutorial. This is Digital Workbench, and I'm 7th Sage. This time around, we'll be getting the input set up and expand the camera from the previous lesson. I'll be sticking to the written tutorial a little closer on this one, with the main change being the demo at the end, which I want to make a bit more directly related to the project. If you missed the first 2 videos, I left a link to the playlist in the description. As you can tell, I got a new microphone this time around, so please let me know what you think. I think it should be an improvement. For now, though, let's get into it. There are a couple big differences here in how Godot handles input compared to Unity. One, the scroll wheel on the mouse is considered a button, sending one button press for every tick of the scroll wheel. The second is that the joystick axis components are split into 2 separate axes for the positive and negative directions. Let's go to Project, Project Settings, and select the tab Input Map. To add a new action, type a name where the text Add New Action is, and click the button next to it that says Add. Once you've added an action, you can click the plus sign next to the action name to add a key binding to it. After clicking the plus button, add a new event. If the field Listening for Input is highlighted, you can press the key you are looking for to avoid having to find it in the list. We'll add the following list of actions and key bindings. Sorry in advance for the long list of keys. For the directional input, we'll create key bindings for move left, move right, move up, and move down. For the button presses, we'll need Fire 1, Fire 2, Fire 3, Fire 4, and Quit. The last set of inputs we'll map will be for the camera input. Camera activate, camera left, camera right, camera up, camera down, zoom up, and zoom down. There are other key bindings that we could add, or you can change them around to be the buttons you like. I tried to have sensible bindings, but you may disagree with some choices and will want to change them. We'll also add mouse controls for the camera, but that will be handled a little different. I also wanted to add that I tried to keep with the style of the original tutorial with how input is handled, but it could probably use a bit of work still. It should be enough to get you going, and I wanted to be able to have at least something to control the camera. So we actually already have a scene created in the last video with most of the things we need here, so the setup will be pretty minimal. I was tempted to save it till the next lesson, but I didn't want to mix up anyone that wants to continue on with the written version. Create a new 3D scene named battle.dscn. Right-click on Battle and create a child node of type Node named Battle Controller. Before we move on, let's create 3 script stubs. Under the Scripts folder, create a new folder named Controller. In that folder, create a script named battlecontroller.gd. For now, the script will just hold a reference to the board and the input and camera controller. Attach the script to the battle controller node. We'll also be creating the next 2 scripts in the same controller folder, inputcontroller.gd and cameracontroller.gd. For the time being, these will both just have extends node at the top and class name. Now that we have the scripts done for the time being, let's jump back to the board creator scene. We'll start by creating a new child node of the root board creator node named input controller. Attach the input controller.GDScript we just created to it, and attach the camera controller.GDScript to the camera controller node. Now that the scripts are attached, select the nodes board, input controller, the light, and all the camera nodes. Hold Ctrl to select multiple, and right-click, select Copy. Back in the battle scene, select the node Battle Controller and paste the nodes onto it, making them its children. With the Battle Controller selected, go to the inspector and assign the 3 variables. Under the script folder, create a new folder called Common, and under that create another folder named Input. Inside Input, create a script repeater.gd. In the original Unity version, there was a longer delay after you first started holding a button before it registered again, and then each delay after was set to a shorter constant delay. I decided to simplify the script a little and keep it all to 1 delay. We'll start with a blank script this time, skipping extends node. Rate is how often the button will register after being held, in this case, 250 milliseconds, or 4 times every second. Next will be used to keep track of the time that has elapsed, and the last 2 variables store which axis is being used. Next up is the init function. This is the object's constructor. So later on, when we have to call something like repeater.new, this is what is called. Don't confuse the update function with any built-in functions. We will call this manually to check if we should call any new events. Start by setting the return value, ret value, to 0, which will stay unless we get input and there has been a long enough delay. Next, we get the axis input and round it to the closest int value. Then, if there is a value, we check if there has been enough time, and if so, we set it to return our rounded value. That wraps up the repeater script. We can save and close that now. Now that we have repeater, let's head back to the input controller.gd. We'll start by creating signals for move event, fire event, and quit event. This is similar to Unity's events. When this function is called, it will in turn call the function on all objects that are registered to listen to it. Next up, we create a repeater object for the horizontal and vertical axis of our movement device. We'll also create an array that we'll use to match the button pressed used. These will be the same names as the actions we created in the input map earlier. In process, we call the repeater's update function that will return 0 unless there is input and enough time has elapsed. If either variable has a value, we call emit on the move event signal, telling all listeners to run their functions. Because of how GDScript handles variables, we can pass whatever type of data through that we need. So in this case, we send a vector to I with both values. We'll add a loop to check each button in turn. If the button was pressed this frame, an event will fire with the button number, starting at 0. No further events will be fired if the button is held. The quit action is similar, but we'll call a specific event for quit instead of the more generic button fire event. Save the script for now. We'll come back to it a bit later. In the written version, we created a test node to check our inputs in the inspector. But this time around, I thought I would put that test code to good use and add a little functionality to the board generator. So let's open up the script boardgenerator.gd that we created last time and make a few small tweaks. The first thing we'll add is a reference to the camera and input controllers like we added to the battle controller script. I realized after recording the last video a small change that will make using the editor buttons a little easier. A reference to the board's pause and height variables using a getter and setter, which will allow us to access the variables in the inspector without switching nodes. In the ready function, we'll add a call to add listeners. This will be where we sign up to watch for the signals we want to listen to. Exit tree will clean up the signals. This will get called when the node is destroyed and leaves the scene. For now, we'll listen to these signals from the input controller: move event, fire event, and quit event, and we will connect them to the functions onMove, onFire, and onQuit respectively. And when we are done, we disconnect from the same signals. In onMove, we'll simply add the value passed through the signal to the current position. For onFire, we create a match statement, similar to a switch statement in other programming languages, and depending on the button pressed, we'll call grow, shrink, grow area, or shrink area. The quit action is similar, but we'll call a specific event for quit instead of the more generic button fire event. We'll come back to this in a bit, but let's save the script for now. Before we can test, there are a couple changes in the board creator scene we need to make. First, on the node board generator, in the inspector, we need to assign the camera and input controllers. Next, to make it so the input isn't competing between the buttons we created and our controller input, select the VBox node and all the buttons. And with them all selected, in the inspector, go down to Focus, and under that, set the mode value to none. Now we should be able to hit Run Current Scene and test out the input and the new functionality on our editor. The cursor should move around with the keyboard or joystick, and clicking the 4 main buttons on the controller should give you the 4 functions from earlier: grow, shrink, grow area, and shrink area. Note that while grow and shrink area will respect the width and depth we set, grow and shrink currently have no such limitation, allowing tiles to be placed outside the range. If you'd like to be notified when the next video comes out, be sure to like, subscribe, and hit the notification bell. Next up is setting up the input for the camera. We'll start with some setup for the zoom function of the camera with the mouse scroll wheel, or alternately by holding down another key. In Godot, the mouse scroll wheel is registered as a button press instead of an axis. It, however, does not register as being held down with the isActionPressed state, but it does register isActionJustPressed. Now I want the mouse scroll wheel and holding a button to feel similar, so we'll create a new repeater class. Back in the same folder as before, Scripts, Common, Input, create a new script named buttonrepeater.gd. This script is similar to the previous repeater, but has a few differences. Here we want a little faster movement for when we hold down the button, so I set the delay to 50 milliseconds. In the update function, the first check is primarily for the scroll wheel, since it will only register isActionJustPressed. It will register every scroll wheel tick, but if the isActionPressed button is held, we know it's not the scroll wheel, and we can check if the delay has passed. Save the script. Okay, back to inputcontroller.gd. At the top, with the other signals and variables, we need to add a signal for the camera zoom and another for rotating it. Rotating the camera won't use any repeater, but the zoom function will use the button repeater we just created. We'll also create a variable to keep track of the mouse position to use when we are rotating the camera with the mouse. In the process function, we'll add a few more button checks for the camera-related input. For camera zoom, We check the button repeater to see if there is any presses or if the button has been held long enough for the next event. If true, we emit the corresponding zoom signal. Rotating with the joysticks is also pretty straightforward. We grab the two input axes, and if either of them are something other than 0, we emit the vector. Here's where the key binding for camera activate comes into play. It's just a key we hold down to tell the game to start listening to the mouse for controlling the camera. So we're only moving it when we intend to. The first check for when the button is first pressed lets us initialize the starting point for the mouse after we hit the button. After that, as long as the button is held, we get the mouse's current position and compare it to what it was the previous time. Then we update last mouse position for the next update. We set a value vector limit to multiply the mouse movement by to get it closer in line to the 0 to 1 value the joystick gives us. After that, all that is left is emitting the mouse movement. And that's all for the input portion. Save the script. Now that we have all the input set up, it's time to move on to the camera controller.GDScript. We'll start with some variables that we'll need for the rest of the script. Follow and follow speed will control what object the camera follows, and how quickly it moves to the next location when it changes. A few variables to control the min and max zoom, as well as one to hold the current zoom, which is given a default value of 10. The last variables we need will set the limits of how far up or down the camera can rotate. In the ready function, we call the zoom function that we'll create later. We'll use this to make sure everything starts out in sync. In the process function, we check if there is a node to follow and use a lerp function to smooth out the movement. After that, there is a function that we will call later to set the object to follow. The zoom function is relatively simple, but depending on whether we set the camera to orthogonal or perspective mode, we use a different value to zoom, position, or size. I noticed a bit of clipping on the orthogonal camera when the distance got too close. So instead of moving both values at the same time, I locked down the position to a larger distance when using the orthogonal camera. Orbit is split into two parts. We use the X value to rotate around the cursor, and later the Y value to handle the upward tilt angle. The big thing to watch out for here is that even though we are using the mouse X value, we will be rotating along the heading's Y axis. Because we are not in the process function, we don't have access to the variable delta. So instead, we could either pass it to this function or call getProcessDeltaTime like I've done here. The two while loops are designed to keep the angle within -360 to 360 degrees. We can't clamp the value because it would freeze the rotation instead of causing it to loop around. So we loop through until we get within the correct range. In reality, it will likely never loop more than once, but better safe than sorry. To make things more confusing, the vertical rotation uses the pitch node's X rotation and the mouse's Y. This time, we do want to clamp the value because we aren't looping in a full circle, but stopping at a specific low and high point set by min pitch and max pitch earlier. I set the range of values to -90 for the camera pointing straight down and 0 to be level with the ground. I am, however, a bit hesitant using a perfect 90 degrees on the camera. There is some potential for odd behavior when rotation is straight above, although it seems like it is fine for now. There is just one more function I want to add, adjusted movement. This allows us to change which way we move when the directional buttons are pressed, based on the camera's orientation. That way, up will always move up, This is done as a helper function so that we can call it when we need, or ignore it when we don't, such as for input in menus. The first step is getting the angle in a format that is easier to understand with rad to radians to degrees, the counterpart to what was used earlier. And then, based on the angle, we flip the axis to point in the right direction. It's a bit messy with the if statements, but it's easy enough to read and works. I've also corrected the values here. They were not fixed until a later lesson in the written version. Now let's open up boardgenerator.gd and add a couple more small changes so we'll have the camera control in our editor to go along with the movement from earlier. To the add listeners function, we need to connect to the camera zoom and rotate signals. And in remove listeners, we need to disconnect them. In ready, we tell the camera controller to follow the board marker. In onMove, we will still be using the same input to control the cursor, but we'll pass it through adjusted movement to make it line up with the camera's rotation. Two new functions, zoom and orbit, will tell the camera to zoom or rotate whenever the signal is sent. And that is all the changes we need to make. Save the script and click Run Current Scene and give the new controls a try. Not as many changes to the code this time. It should still be very compatible with the written version, but I think the extra controls in the editor this time around should prove useful for a lot of people. I noticed a small error in the boardgenerator.gd code that was added in this lesson. Because it was not meant for the editor, it will display an error, though it will still run. To fix it, we'll wrap the code that doesn't run in the editor inside a check. If you have any questions, feel free to comment below or check out the repository on GitHub. I've left links in the description. If you'd like to support me or find me around the web, you can find me on places such as Patreon, Twitter/X, and itch.io. I've left links in the description. I've also created a Discord channel for you to ask questions if you get stuck, which I've also left links to in the description. Special thanks to my patron, Joshua Strode, and also to Peekaboo on Ko-Fi. And special thanks to John Parham, the original creator of the Unity tutorial, without which this wouldn't be possible. Thanks for watching!